With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
This problem says that a copper wire bent in the form of a shape of a semicircle of radius small r translates in its plane with a constant velocity v. A uniform magnetic field B exists in the direction perpendicular to the plane of the loop of the wire. Okay, so find the EMF induced between the ends of the wire if in first case it is given the velocity is perpendicular to the diameter joining the free ends and velocity is parallel to this diameter. Okay, so consider this is the diameter is basically P and Q, and this is its center. The radius is small r, so if CQ will be small r, then CP will also be small r. So total diameter, or we can say that total length of the diameter will be 2r. Okay, so this is the total length of the diameter, and in first case it is given that the translation motion of the copper wire of this loop, okay, is perpendicular to the direction of magnetic field. So this is V and this is the magnetic field. Magnetic field is perpendicular and into the plane. Okay, now we can say that here this is also the magnetic field direction for case B, and it is given that if this is C, this is P, and this is Q, and this r is the radius of this semicircular wire, then it is given that the velocity of wire is along the diameter, that is parallel to its diameter. So consider this velocity is also v. Okay, now consider this case is case A and this case is case B, and for both of the case we have to calculate EMF. Okay, so we know that EMF induced between the two ends, or we can say that motional EMF between the two ends of a wire in the magnetic field region can be given as V cross B dot L. Okay, this is the basically triple scalar product. If any of the two physical quantity will be parallel to each other, then EMF will be 0. Now let's look at over here. Here V is in x direction, B is in negative z direction, and L is basically the length PQ. Okay, so L is in basically y direction, we can say. So all three are mutually perpendicular to each other. So we can see that V, B and L, all three are mutually perpendicular to each other. Okay, so mutually perpendicular to each other for the first case. This is I am talking about for the first case. So if all of three are mutually perpendicular to each other, then V cross B dot L can be written as VBL, and we have given V as V, B as also B, but L can be replaced by 2R. So EMF developed between the ends of the diameter will be 2VBR. Okay, and this is the first answer of this problem. Now let's talk about the figure B. Okay, so for this figure, if we talk about for this figure, we can see that V and L are parallel to each other. V and L, this is L basically this is L vector. Okay, this is L. Okay, so V and L are parallel to each other. Okay, so V and L are parallel to each other. So if we have already said that this is EMF is basically triple scalar product. So if any of the two physical quantity will be parallel, then EMF will be 0. Okay, so we can see according to this situation, the EMF developed across PQ for this second case will be 0 because V and L both are parallel to each other. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.